stuck. That's okay.
You're stuck.
Yeah, I'm stuck.
All right. I'll introduce you since.
Yeah.
Why not? Yeah. Well, thank you for coming. I'm Sarah. I'm the Adult Services Librarian here at McFarland. And we are very honored to have Project Home and MG&E here with us. We had them last year, a fantastic class, and we get to have them back again this year for Saving Energy. So we have Brendan from Project Home and Laura from MG&E. So, all right, thank you.
Yeah. Okay, so yeah, thank you for coming. So today we're going to be learning a little bit about saving energy in your home, and this goes for year-round. This isn't just for wintertime. This is for all year round. So this presentation is brought to you by Project Home and MG&E. Thank you to E.D. Lack Public Library in McFarland for hosting us. So Project Home, we do a lot of different things at Project Home. Home repairs, weatherization, affordable housing, and our Optimist program, which is our social enterprise program, more or less a contracting service that allows us to take whatever net profit that we have and gives it back to the nonprofit part of our company. So Project Home, every home safe and sound is our motto. So, little introduction on us, who we are. My name is Brendan Shoemaker. I've been with Project Home since 2008. I'm Senior Residential Energy Assessor, also a BPI Building Analyst, and recently, and I do need to fix that slide, but recently I became a NABCEP PV Solar Associate, so that's photovoltaic solar. I took that test recently, and so now I can put that on my resume as well.
Nice.
And Laura.
I am Laura Paprocki. I also am a BPI analyst. I spent 12 years doing energy audits. So climbing in lots of attics, crawl spaces, doing blower doors, infrared cameras, camera scans. But I am now at MG&E. So I've been able to bring all of that information from the field into my job at MG&E, and I get to continue to talk to people about conserving energy and what makes what's the best, improvements for their situation, because everybody's situation is different. So thanks so much.
So to go right into the presentation, so this is one that a lot of people see that is awfully familiar driving through neighborhoods in the winter. Another one that is, so our bill is brought to us by MG&E that show us how much energy we're using compared to the rest of the neighborhood. So every house uses some form of energy. It's really up to you how much it's going to use. There's a few things that are constants, like how the home is constructed, what the size of the home is, what kind of mechanical system, and the climate in which the home is located. Ours is obviously a colder climate, although with the global warming trends, we do start to get a little bit warmer every year. So, but the types of heating energy that we use in our homes, natural gas, propane, fuel oil, those are probably the three most common that I run into when I do energy assessments. Electrical is another one that I do run into as far as just heating with baseboard heaters. Wood and pellet stove, something that you would find more in like a rural location. And then renewables, which is certainly a different way to produce heat or energy in your home.
And today we're going to cover a lot of building science. And what's awesome about building science is that it covers everything that's happening in your home. So it's not just the movement of heat, but it's also air and moisture and the flow of those in the building and how they all work together. And all of them play a role within each other or combined with each other. And when I would do audits, the best thing was that you could analyze a home and use all the building science knowledge that you had in order to allow people to understand what was the next best move for them in terms of home improvements. And you weren't selling them anything other than data. And people really appreciated that because oftentimes other people telling you what to do are financially motivated because they might be selling one of the products that they are suggesting that you improvements that you make. And the idea behind building science is that our homes are a system, and we are never really taught this. We buy a home, a house, it's sometimes the largest investment we'll make, and yet there's no manual for it, right? And yet it does have its own way of functioning, and it's a system. And in this picture, we see a house and we see some red arrows, and that's just an indication of warm air rising. And then the blue ones are cold air coming in down low. But all the different areas of this house can affect the airflow. Like when your heating system kicks on, it can pressurize or depressurize certain parts of the house when you run your dryer. People often don't think about it, but it's like a huge exhaust fan. So like, how bathrooms are supposed to have an exhaust fan, and like when you cook, you should put on an exhaust fan. People don't think about it, but that dryer is venting like 400 CFM, which is just a measurement of air movement. So it's moving a lot of air. So that means it's actually affecting the rest of the house. It's throwing the air out of the house, which means other air is coming in. So building science and understanding how to save energy really takes into account this idea of the house as a system. And then usually I like to do a little quiz, take everybody back to 8th grade science and ask them if they remember the 3 ways that heat is transferred, which in this case, we'll just give the answers away, but you've got conduction, convection, and radiation. And part of building science that in how it interacts with a home, which is really cool, is that oftentimes we learn so much about science, but it's never applied in a practical way. And building science is like the most practical, daily application of science that as an engineer, I have found to be true. And so I love to just go back to these really basic scientific theories, or what we know is what we're studying here is energy and heat. And so it transfers. I mean, we produce it in our home and then it transfers to the outside, or in summer, it transfers to the inside. So these are the 3 ways, and we'll talk a little bit more about each one of these in terms of how to make upgrades in order to improve how each one of these transfer mechanisms affects your bill.
Yeah, one thing to add to that is, thinking about the 8th grade science and, the ideas of the 3 main ways that heat is transferred, but also thinking about it is like further on, when you're talking about like thermodynamics and you're talking about, rule cannot be created or destroyed, right? It's always there in some form, whether it's latent or, kinetic. And in these ways, just showing that, the fire, you've got 3 different ways right there. Is it transferring through a material? Is it transferring through an air movement, right? Or is it transferring through another source, the radiating source? So that's, for some people, you can take it to even a greater point and help to focus that in. When I do audits, a lot of times I'm going at a very 8th grade level, to make sure that they're understanding that. But there are some people that really need that a little bit more data, a little bit more science back to it. And I'm always happy to give as much science as I can from all of my background in physics as well.
Yeah. So one of the most important things we're going to talk about, and that building science covers really well, and that we don't think about, but plays into this idea of the house as a system, is that at any moment in time, your house has air moving in and out of it. And the volume of air in your house is always going to be the same. So if any leaves, that means some comes in. And we have a number of different effects. The biggest one we talk about in building science is called the stack effect. And we call it the stack effect because it's like referring the stack as like a chimney. If you think about it, like we use chimneys to remove the hot exhaust fumes from a fireplace often or some other combusting piece of equipment. But our homes are doing the same thing. We don't think of them as a chimney, right? But they are, a structure, and within that structure, warm air is rising. That's something, we learn as little kids in science, right? And so when that warm air rises, it can use that pressure to actually push up and out of the house, and that's energy loss. And then the cold air will come in down low, and then suddenly you have that cold air that came in down low. Now you have to reheat that up. But there are other pressures on a house. When the wind is predominantly blowing, like let's say in winter, from the north and the west, that creates air movement within the house too. So you have all this air movement occurring within buildings. And in building science, we talk about making buildings airtight. And these are some of the effects, that we are working to combat against. One of the biggest reasons we care about the stack effect is because most of us have attics. And above those attics are roofs. And what happens to some homes, if you don't have good air sealing, is that warm air will get up into the attic. It actually warms up the underside of that roof sheathing. And then when you have snow sitting there, it's actually insulating, so then the underside of the roof sheathing is getting warm. It's warming up, the snow or ice that's on top of those shingles, and then that is melting, moving down the roof, and then refreezing at the eave. And then it continues to build up to the point where you can actually have some of that ice and then water working its way up underneath the shingles into the home. And, you'll often see this then as like, maybe sometimes it's dripping water or drips coming down like a ceiling fixture or an outlet, or you might have
Stains on the
you might
edges
see
of the house.
staining. And so we care a lot in building science about air movement, stack effect, warmer rising, because this not only is energy loss, but it can be lots of damage. And there's known ways to remedy this, which is what we're going to get into. Anything else?
No, I think that's when we have done audits, we've run into significant roof leak issues before. You have, I have. Sometimes it's caused by ice damming, sometimes it's just caused by other things. But ice damming is one that's super preventable, and that's something that further down the road we want to think about. That is, since this is such a huge investment in our homes, that we want to have something that is going to be properly insulated, properly air sealed, so that you're not running into this, because this issue alone can be thousands of dollars worth of cost, right, to repair.
To repair, yep. So we're going to talk about air sealing, so how to make sure that air stays in the home and doesn't come up into the attic. And then, of course, I was going to make sure you have proper insulation levels in the attic. And then the last thing, it still is important, but less important when you do the first two, is attic ventilation. So you might be familiar with attic ventilation because you may have had a ridge vent, like right along the top of your house put in. You might have the pods, they're like squares that you see. And if you have a part of your house that hangs over, like the soffit, and you look up and it's perforated, that is also part of the venting. So air should come up through the soffit and then in and then up and out through either the pods or the ridge vent. And the idea is like, it's a belt and suspenders approach. And what I mean by that is ideally you air seal the attic and insulate. That should take care of that warm air rising up. But in the event that, something happens down the road, then that good attic ventilation carries that heat up and out. And then just lastly, like air leakage is, this is an interesting slide because everybody, when I would do audits, was like always so sure. They're like, oh, you're gonna find that my windows just leak a ton. You know, they're like, oh, we know where like all the leakage is happening. It's like from that door and the back door, and you know, and I would appreciate that. But the real actually areas that add up the most amount of leakage are the ceiling and the walls and sometimes the floor, right? And then we see these other things, plumbing holes, those are usually in the attic, right? So that's actually part of like the ceiling. But it's just so funny that windows and doors get so beat up, you know, about being so leaky when it's actually, you know, almost 80% of the rest of the house that's doing the majority of the leaking, and it's not getting in trouble for it. But that's where like doing the blower door, having an energy audit, which we'll get into, and doing an infrared camera scan really will open homeowners' eyes to actually be able to see the leakage. With thermal imaging, you can actually see the leakage happening, and you can see the areas. And I can tell you, it's not always the doors and the windows.
So between the two of us, we kind of looked at 6 project areas. Definitely will help with identifying some of the common energy problems. In this case, air sealing insulation, electrical base loads, HVAC and water heater upgrades, ventilation, water savers. So right from the top, air sealing is really what I would consider to be kind of like the down and dirty things, right? So at Project Home, this is kind of our bread and butter. Air sealing and insulation are the things that we do the most, and we do them really, really well. We've been around a long time. We know the building science. We're all trained in how to do it properly, and it's not something that people think of that much, which is evident by the fact that when you go into an attic and I can clear away some insulation, and there's all of these areas of air leakage. So, I mean, right here on the slides, you can see, the caulking, the foaming, all these things, common air leakage spots around chimneys, around, like I think that one on the right is the range hood coming up from the kitchen, above the kitchen stove. All of those are what we call bypasses. So that's where air is able to, especially warm air, is able to move upwards and get up into the attic, which then can also create those ice damming issues and other mold issues as well. Like you said, plumbing. Plumbing's a big one. Soil stacks, PVC or cast iron soil stacks, usually big gaps. Electricians are really good at drilling a 1-inch hole for a 1/4-inch piece of wire, right? So electricians, we love our Sparkies, but still, they cause a lot of air sealing issues. And then even, looking at the wood, the framing here, this is just the top plates of the framing of the house where the drywall abuts. All of that needs to be air sealed as well, because that's still areas that air can move through. Again, this is, here in a range hood. If you looked above the kitchen stove, you'd look in the cabinet, you would see that that range hood just totally unsealed there. It's just cut right through the drywall. So, I mean, all of that air can move right through there. Or into soffits, drop soffits in kitchens, which was really popular from like the 50s until mid 80s. Almost everybody had drop soffits because their cabinets didn't extend all the way to the top of the kitchen ceiling. All of that needs to be sealed. If you really want to do a proper job, you have to get this all sealed. Like I said, the air sealing and the insulation are kind of like the dirty pieces of home energy savings, but they're so important. And I like to think of the air sealing as the windbreaker and the insulation as the sweater, right? So if you're just wearing a sweater, but you're not wearing a windbreaker when it's windy, you're still going to get cold. You put the windbreaker on and now you feel a lot warmer. So types of air sealing materials, foam is really the most popular one because it can get into all the cracks, it cures, it creates a fairly permanent air sealing. Caulk is very good too. Different kinds, silicone, latex, high temperature caulk, which would be used next to potentially a chimney or any other combustible type of chimney, appliance source, flue, right? Yeah. Weather stripping for windows, doors, plastic over the windows, that is a way of air sealing. metal for around chimneys, which is to keep the insulation from being right tight against the chimney, which could be a fire hazard. Unlikely, but also something that is a code. So air sealing techniques, here they're using different types of caulks, different types of foams, insulated boxes that go over can lights. You can get really into air sealing, and it can become this whole huge project. There are ways to make it a little bit easier. I find that, like I said, using foam is good. It's a little bit more expensive, but it does make a huge difference, especially if you can get to everything. Why not use something that's actually going to be able to get all those top plates, all of those bypasses. Now, these are things that maybe people aren't necessarily going to do themselves, climbing up into their attic, clear all the insulation away and start air sealing. But there are places that you can get to in the basement. We'll talk about that too. But in the basement above your foundation wall where you've got, plumbing, like the spigot to the outside, that plumbing going to the outside, it's completely unsealed, or the AC, usually AC is a big one, big hole and not that big of a piece of equipment that goes through that hole. That needs to be air sealed because that's where a lot of that cold air is coming in, where the infiltration is happening. We call that the infiltration at the bottom, the exfiltration at the top.
And I just want to say that we talked so much about air sealing because it hasn't been talked about before. I mean, it has been talked about before, but it's often overlooked by homeowners. It's like everybody knows about insulation. Lots of people grew up with the Pink Panther. They get it. They get more insulation is better. But you will hear anybody who knows anything about building science always say you've got to air seal before you insulate. You can't just add more insulation on top of your insulation and think that that's like going to stop those leaks. It just doesn't. We know air moves through all types of insulation except for spray foam. And so we just really always repeat this message, like always air seal first, especially when it comes to the attic, so that's an absolute rule. And when you're talking to contractors, if you talk about air sealing and they don't know what you mean, you might want to talk to a different
Find a new contractor. Yeah, absolutely. So insulation. So this is the part 2 of that, right? Is like you said, with the air sealing and insulation, they have to be done together. They have to be aligned. And if they're not, you're not going to get the most effective energy savings. So attic insulation, we lose most of our heat through our ceiling. So certainly insulating at that level is going to be the most important. Walls you can do low in cellulose. They can dense pack the sidewalls. I'll have some slides coming up where you can actually see what I'm talking about. The box sills, which is the area where the floor joists are right above the foundation wall. All of those we call the box sills. Those are often, I go into a lot of homes where those are uninsulated. And even if they are insulated, they're not air sealed. Basement walls, rigid foam board. A lot of people use fiberglass. I'm okay with either of those. And then roof decking, which is, this guy blowing all this this foam onto the, so that's like $1,000 worth of foam probably right there, to be honest. So it's very, very expensive. And it has to be professionally done because they bring big truck with 2 mixing components, and the liquids mixed together, and they create this foam that expands and cures. And it's got a very, very high R value per inch, but it also comes with a price tag.
Yeah.
So, yeah. So, like I was saying, aligning the pressure boundaries. So if we're talking about like the interior drywall, that's our pressure boundary. So this is our pressure boundary. What's behind it, if this was the outside behind this, right, that would be where we would want the insulation. And we want it tight against that surface. We don't want to have an air gap between the pressure boundary and the thermal boundary, because air moves through very readily through. So we have to have those things aligned to stop that conduction, and also to help slow down that the conduction, but also to slow down the convection. So in the attic, we looking at our 50 to 60 of blown in cellulose. So this is like anywhere from 16 to 20 inches of cellulose insulation. We really like cellulose, and we prefer cellulose. We would prefer everybody use cellulose because it is a less expensive material. It's recycled, and it has a very, very high R value when it's blown in properly. So it does have to be installed properly, but you can see here it's a loose fill. And then the picture on the right, this is actually one of our Project Home employees doing a dense pack under floorboards, which is another place that also gets overlooked because air moves through those floorboards. If you just blow insulation on top, you're missing all of that piece underneath where all of that conduction and convection is happening.
Floorboards in the attic.
In the attic.
Yeah, in the attic.
The walls, so dense packing the sidewalls. Most of this is done from the outside. Typically, it's done from the outside. Some maybe need to be done from the inside, above doors and windows, because the eaves sometimes hang down so low that they can't get it from the outside. But typically, they're doing it from the outside. And they're taking a piece of the siding off, whatever the type of siding is that's there, except for like stucco and translate siding. And they're drilling a hole into that sheathing on every cavity. And they're putting a hose up and down that wall, and they're packing it full of cellulose insulation. And that does really three things in my mind. Number one, it fully insulates that cavity. It mostly air seals. The air will still move a little bit through it, but it'll be really, really very reduced. The other thing is soundproof. It makes the house a lot more soundproof. Whenever I dense pack sidewalls, especially if it's like a garage wall and like a garage ceiling, when we dense pack that and now it's soundproofed, and then people, the people that lived above their bedrooms were directly above the garage, and now they're like, oh, I can't even hear the garage door open anymore. So,
Yeah, people would always say, like, I'd be like, oh, what's the thing you're most excited about now that you've insulated the house? And they're like, it's so quiet.
Yeah.
And I was like, yeah, there's that too.
We certainly believe in the energy savings of everything, but we also believe in the comfort.
Yeah.
And
Absolutely.
comfortability is really a very important piece of building science and of what we do to make sure that every occupant is comfortable. The more comfortable, more cozy the house is, the more they're going to enjoy living there.
Absolutely.
So we talked about the box sills, and again, this is the area just right above the foundation wall, in between the floor joists. Usually an area that's not air sealed and really very poorly insulated most of the time. So if it's possible, you use spray foam there, if it's possible. If it's not possible, you want to air seal it with foam all the way around, like a picture frame, all the way around, and all of the penetrations through that outside joist, right? We want to make sure that all of that is air sealed and then properly insulated with good fiberglass, like at least an R19 of fiberglass. So this just kind of further shows, the air sealing that can be done on that rim joist, because there is a ton of leakage that comes in through the basement, especially this area. Like when we talked about the stack effect, we're getting that infiltration of cold air in the winter at the bottom, which is why part of the reason that the basements always feel cold, right, is because you've got all this cold air moving in and out, or moving in, and then you've got all that warm air that's getting pushed out. Because no matter what, your house is always going to have the exact same volume of air. That's never going to change, no matter how much you turn on fans and everything like that. The volume of air is always the same. So when that cold air moves in, it's moving the warm air back. It's moving the warm air outwards. So it's just replacing cold to warm. So that just gives you a little idea on different ways you can air seal. It can be done with caulk. Caulk's harder to do because it's harder to get that like caulk gun into all those areas. That's where sometimes that spray foam, even the stuff that's in a can, you can just whip right through it.
Okay, so thank you. That kind of concludes air sealing and insulating. So we showed you these six different areas. of different improvements. So we talk about air sealing again first because it's the most important, and then insulation. And now I'll talk just a little bit about after that, right? After you've like really put on the sweater and the windbreaker,
Yep.
then you can start looking at things like, well, gosh, what do I all have plugged in, right? And so, appliances, old refrigerators and freezers, or the second, refrigerator or freezer, see if you can get rid of it. That's pretty common, knowledge. It's just the less you have, the better. We still talk about lighting, like most everybody has transitioned to LEDs, but it's still important to remind people that, it is really good to get rid of the incandescents. I mean, they are considerably more expensive to run, and so changing everything out to LEDs is definitely the way you want to go. And then after the big ticket items, like the second fridge or if you can get your, get any of those unplugged and then take care of lighting, then you start going after like these other smaller loads, but just as important, that kind of add up, right? And there's a lot of gadgets, I'll call them now, that really have helped reduce some of this like ancillary energy use. It's like, every TV now is controlled by a remote, which means that even when the TV's off, it's using a little bit of energy because it's waiting to receive that remote. And then, any other, you think about like a DVD player, a cable box, a gaming console, speakers, like so many of these things all will have, even if it's just like a little red light to show you where the on and off button is, or if it's got a clock on it. All those things are using little bits of energy. And, given everything that's going on, global warming, people might say like, well, those are just little bits. But we're at a point where all the little bits are making a big difference. And so you can make a big difference by just using some of these things like smart power strips. The power strips on the bottom, those aren't just plug in and then turn it on off on a button. They're smart in that they have a plug-in that kind of is considered like the control. And let's say it's the TV, you plug the TV in there. But then you plug in anything that you would use only when you're using the TV, like if you would have speakers or a game console or a DVD player or like a cable box. Some of the things you have to be careful with, but for the most part, if you think about it, you're not using those other things unless the TV is on. So why would we send even just little amounts of energy to all those other appliances? We shouldn't. And so that's what the smart power strip recognizes. It knows whether that's the TV is on, then it'll send power to those other things. But if it recognizes the TV's off, it's going to say like, sorry DVD, sorry game console, sorry everything else over here. Like you're just not going to get any energy, right? So it stops that phantom load. Same thing, different example. You plug a computer into the control and then say you have a scanner, a printer, speakers, like in the other ones, it's like you never use those other things unless your computer is actually on, right? And then there's other really cool things, like smart plugs that you can plug in and then you can control with your phone, adjusting your water temperature, setting your refrigerator to the appropriate. So there's all these little adjustments you can make to kind of fine tune your electrical usage.
I have a question
Yeah.
about the refrigerator one.
Yeah.
So it says set the refrigerator to 38 and the freezer to 0 to 5.
Mm-hmm.
What does it typically come already set at? Like, are we decreasing the temperatures or increasing the temperatures?
Increasing a little bit. It's usually the refrigerator is somewhere between 32 and 35
Okay.
is the standard setting, and below 0 for the freezer. So
Gotcha.
even just like those small adjustments,
Mhm.
even if it's 5% of the electrical use, that's a significant amount. So, yeah, and
As far as those smart plugs work, how does does it notice when it's like completely off, it just turns everything off, or do you do it via like an app? Like how does that
No, it just
particular science.
knows. It knows that plug-in has like a way to measure the like electrical, I guess, power going through it. And so it will know whether that TV is on or off. It just knows. That's and there's even controls on these smart power strips. For example, if you use a laptop, but when the laptop is on, it might not send like enough of a message through that. You can actually adjust it to say like, hey, I'm using something in this control plugin that's not gonna use as much energy. So like I need to adjust the setting on the advanced power strip. So yeah. And then other electric base loads, we call them, is like, and this is a big one. I always talk to people at MG&E who want to call in and talk about reducing their energy use. I almost always have them walk over to their thermostat and tell me, what is your fan set to? So all thermostats, you'll have like your heat, cool, off. Most people like get that. They know I'm just going to be on, but then there's that other button, toggle. It says fan. And sometimes people won't even pay attention to it. And what that is that's talking about the big fan down in your furnace that blows the air all around, all over the house. And if you have that toggle to on, it means that big fan is blowing 24 hours a day, 7 days a week. And there have been some like misunderstandings around like, oh, that's good to have that on. Like you want to move the air through the house all the time, but like there really is no research that proves that it like makes you any more comfortable or it's any, better. It's just using energy. So you really want that to be toggled to auto, which means that fan's only going to come on when that furnace calls for heat, or the AC turns on. I'd argue the only time you ever would want to run it on is if you have somebody like highly sensitive to allergies and you have like a special filter, on your furnace that is pulling some of those allergens out, like maybe then. But so that's another one. And then
You can start.
Okay, so we're going to talk a little bit about this next one is you may have heard of the term electrification, and some people haven't. And so that's why we are out here talking to everyone. So the idea behind electrification is we want to use energy efficiently. We want to bring renewables onto the grid, right? And then we want to electrify everything. So global warming is happening, right? We want to move away from using fossil fuels. Natural gas is a fossil fuel, right? So electrification is moving things that had used natural gas in the past to now using electricity, but in a more efficient way by using a technology called heat pump technology. So is really this idea of like, wow, we are now bringing a lot of renewables onto the grid. Our electricity is greener, getting greener, getting greener. MG&E has the goal of 80% carbon reduction by 2030. I'm happy to say that we are halfway there. We have reached 40+% reduction in our carbon, and that's from bringing renewables on. And so when your grid, the energy mix in your grid gets cleaner, that's more incentive for all of us to use electricity when we maybe otherwise would have used natural gas or LP or fuel oil. And so that's what electrification is. So when we think about what uses natural gas in our homes, furnaces, water heaters, dryers, sometimes you cook with natural gas if you have a natural gas range, if you have a fireplace, but those are the big heavy hitters. So we'll talk a little bit about that. So we'll talk about heat pump technology and what it is. And so, the motivation behind this is really to move things to use electricity and in an efficient way.
And, certainly in the, and I think about this too, is, in the debate the other night, they were talking about, energy consumption that, Americans use. And, both candidates, mentioned fracking. Fracking is a way to get natural gas, is to produce natural gas. But it's a rather dangerous way of doing it. because it can really have very big environmental impacts. And so we have to be very, very sensitive about, what those things are doing in order to get that energy. And the less that we can do to damage the environment, especially like really, really natural areas, the better. So if we can use sources like wind, if we can use sources like solar, if we can use more hydroelectric, all of that can build up our electrification. We can expand our grid and be able to heat our homes more efficiently with things like a heat pump, an electric air source heat pump. So these are fairly new slides for us because a lot of this is, I'm not going to say this is emerging technology. It's been around for a long time. But for our climate, these are a little bit more emerging technologies. So in this case, this was actually a project that I did. The house previously was an all electrical home, so it's only being heated with baseboards. And baseboard heating is okay, but it's not the most comfortable type of heat. So
It's also really expensive.
it's very expensive, right? So electricity, when we use electricity, it's 100% efficient, right? All of the heat that's created goes where it's supposed to go, but it's not always the easiest thing, and it's also very expensive. So in this case, when we're looking at cold climates air source heat pumps, CCASHP, so they're getting way better. And at this point, we've got them that they're designed to go all the way down to negative 15 degrees. Design temps do vary. In our climate, this is more or less what I want you to think about. This is like an AC that can be run in reverse. Okay, so it can be air conditioning and it can be heating. The heating piece is generally the more touchy piece. And if you have a home that's maybe not that's not as efficient because it hasn't been air sealed and it hasn't been insulated properly, it's going to be harder to heat the home with just a heat pump. But it is possible. So this house, we were able to put these two heat pumps in, and we were able to put, these are a head or a cassette that would go on the wall. And you may have seen these at somebody's home or also in a commercial building. And the heat gets transferred through the heat pump and out through the cassette, right? And it can, like I said, it can be run in reverse, so it can also be for cooling. A lot of people will use these types of heat pumps or what we call like a split system or a mini split or a dual split. You probably have heard those words before. When they have a boiler and they don't have forced air, so they couldn't have central air, but they use this instead for their air conditioning. Now, instead of just using it as air conditioning, it can be used both ways. So heat pumps have been around for a long time. This technology is not new, but it's primarily been used in the Southwest, and mostly for cooling. But they also do have shoulder months where it can get cold. I mean, you saw in 2021 when they had that crisis with their grid in Texas, right? And that's where they needed to have heat pumps to be able to also kick in reverse and use some heat. Unfortunately, their whole grid went down, so that was a bigger problem. But so we will talk about hybrid systems. So there's hybrid heat systems. So right now, not everybody is fully on board with just heating with a heat pump. So the hybrid system would be almost like you have your furnace like you normally do, but the heat pump on the outside would be able to either assist with the heating of the home, or it can be used just as the heat source for the shoulder months. And when I say shoulder months, I'm talking about September to November or March to May. Those are our shoulder months where, we still have some cold days, right? There's still some cold days. But a lot of that, we can take care of that with just the heat pump technology, and we're not having to worry about burning fossil fuels. So some people feel, especially up north, that this hybrid heat is the way to go. Do we consider it a better option for Wisconsin winters? And this is where the discussion would obviously happen. So
I will say, like, there are some people who have called into MG&E and they have gone all electric. Like, they have gone with just the heat pump. And if they've insulated, which they almost always have done a really good job, they know, they've done their homework. They know they really needed to insulate and air seal their house, and they have. Maybe they have solar too. They are making it happen, and they are not spending any more than they would have with natural gas. Then but if you didn't like insulate and air seal and you weren't careful, and you got rid of your natural gas furnace and just used the heat pump, you would see an increase on your bills. So it's a fine dance, and a balance, just like everything in life. There are some people who are incredibly motivated to go all electric. And so they're like, doesn't even matter to me if it's a little bit more, or not a little bit more, but more expensive, because it just depends. They're willing to do it. But if you do the hybrid, you usually come out about cost neutral, meaning you're not going to end up spending any more or less on heating and cooling than you would have with just your natural gas furnace. And if it helps to think about this, the same thing is happening in the transportation industry. We have driven industrial and combustion engine cars for a very long time. Okay. Now, and then the first step was a hybrid EV. So this is a hybrid heating system, right? And then just the heat pump would be people who move to have a full electric EV, right? Where it's there's no gas going in that vehicle. It is all electric. So all industries are moving, in this direction. And this is this wave of electrification. So it's happening in transportation, it's happening in buildings, etc.
So heat pump technology, not to be too awfully boring with it, but like I said, it's an air conditioner that can be run both ways, right? So and people sometimes are like, well, how can you create heat from negative 15 degrees outside? The heat always exists in all forms, and the design temperature, you're going to get cooler air coming out of that cassette head than you would be if it was maybe 30 degrees outside. It's going to be cooler, but there is still going to be heat. And that's obviously the biggest debate right now in this emerging field is, can we actually fully and safely heat a home with just a heat pump? The home that I showed you where we did that project, we went out there when it was the days in January that we just had this year, where there was maybe 3 or 4 days where we were at negative 20, with the wind chills, negative 25 with the wind chills, whatever it was. And it was very, very cold. We went out there and they were comfortable. So it worked.
That's awesome.
We did a very, very good job with all the with making sure that the house is fully sealed, fully insulated, and hey, it worked great. And so, case by case basis, like Laura said, it's going to depend on what are the other behaviors of the house owners. So,
and one thing that is a fun fact, 2 fun facts, is that heat pumps are 300% efficient. And you might say wait, what? So I'll say it again. 300% efficient. What that means is for every 1 watt, which is a measure of energy, that you put into a heat pump, you get 3 out. So you might ask well, if it's so efficient, why did you just tell me my bill would go up? And that's because it is a very efficient technology, but it is still using electricity. And we are so used in America to incredibly economical natural gas, because we have had such plentiful domestic natural gas for so long that we have to remember, whenever we think about something being expensive, we're always comparing it to something else, right? It's always expensive in comparison to something, right? That pair of shoes is $40. That pair of shoes is $140. That pair of $40 shoes is what makes the $140 pair of shoes seem expensive, right? So we're coming out of this era where natural gas has been very economical, right? And so the cool thing about heat pumps is they are incredibly efficient, but we are using electricity. That being said, it also ties into, again, the fact that we want to use energy efficiently, bring on more renewables, and then electrify everything. So you have to remember the energy, the electricity that we're using, okay, is greener, 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 right? So it's going to make more and more and more sense as the grid gets cleaner. And the important message too is that when you buy this equipment, it's often then in your home for 15 to 20 years. So we're encouraging people to remember that like your carbon footprint, the choice you're making today is going to affect you for the next 20 years. And seeing as though the grid's getting cleaner and cleaner, like they have already done the research, and it's not us, it's other parties, to say choosing a heat pump technology now is in your best carbon footprint interest in the long run, right? And then the other fun fact is that when Brendan said, like, how can you get heat out of negative 15 degree temperature? I always love to remind people that like there is heat existent all the way down to absolute zero, right? So,
0 Kelvin.
it's possible.
So air source heat pump water heaters are another thing. So this is obviously a little because you don't have to worry about like design basement generally, but same, right? So you've got this ability to draw air in. It takes the heat out of that air. It kicks out the cold air, and whatever heat that is using then is going to the heat exchanger to heat the water. The picture on the right is actually I took that just a couple of days ago in our office. So we had a incredibly inefficient electrical water heater for as long as the building's been there, and we switched out recently with this air source heat pump water heater. So
Very cool.
And in general, for a house maybe like 2 or 3 people that are using energy, that are using like a little bit less hot water than maybe they don't do wash every day. They don't take really long showers. They're not doing a ton of dishes and things like that. You can usually get by with just using it as a heat pump and a heat pump only. But it does have the ability to switch over from heat pump to a hybrid, right? Where now you're using a little bit of electricity to help heat that water, or even to go just full electric. So it can become a whole electric water heater itself. And that would be if the demand was very high. Maybe at a house full of people at Christmas and everybody's using all the hot water all the time. It may switch over for a while to the electric only, just to make sure that it's meeting the demand. But the hope is that you can use it mostly as the heat pump or the hybrid to heat your water. So because these are so efficient, they do create condensation. Because warm air going across a heat exchanger is going to create condensation, right? There's a swap of warm and cold air. It's going to create condensation, and there has to be some drainage there. So you do have to have an area for the water heater to drain, either do a floor drain or if there's a condensate pump that could pump that out. So there can be some extra peripherals to this.
But that has some silver lining.
It does, and I bet you're going to talk about that right now.
Well, I mean, unless you were, is that it's removing moisture out of the air. And in Wisconsin, we all have to run dehumidifiers in the summer. And so it actually helps dehumidify. I don't know if it helps dehumidify to the point where you don't need a dehumidifier. I don't know that I can say that, but it's going to help your dehumidifier run less.
Yeah, and some people use a dehumidifier just in one part, utility area.
Yeah.
So it may make up for that, or at least reduce what the dehumidifier has to do.
Yeah.
And with minimal effort. So the other piece to that then with the dehumidification is the fan does make a noise, right? So there is a little bit of a noise, but the other thing is you're taking a lot of that heat out of the air. So in this case with our water heater, this is in our server room, which the server creates a ton of heat.
Oh, that's so cool.
So, what used to be we had to run ventilation fans in there because it would just get so hot. And now it stays at like a perfect 72 degrees pretty much the whole time, so.
Oh, yes, I had a customer tell me that they purposely put their deep freezer in the same room as their utility room because they were getting an air source heat pump water heater. So we know that freezers and refrigerators are also heat pumps. They're kicking any heat that would be inside there out, right? It's a compressor, right? And so if you've ever felt around like your refrigerator, sometimes you actually can feel like the warmth. Well, if you put that where your heat pump water heater is, it's like they are now two synergistic, happy pieces of equipment.
The house
helping
is a
each other.
system.
The house is a system.
There was another piece that I totally forgot, so I'll let you go right on to smart.
If you
fixtures.
remember, just interrupt,
Yeah.
because aging brains can't pass up
Yeah.
spontaneous moments of remembering. So other upgrades that help people save energy are smart thermostats. Lots of research on this. They're really easy to use. They get to know your behavior and then they just save you energy. And lots of times they do that by recognizing if you just left the house, then they'll turn it down, you know. They're super convenient. You can know you're coming home and you can turn it on.
Geofencing.
Yeah, and MG&E, we, are more and more becoming like a conductor of energy, and with other people's help, we can go further, faster towards goals like decarbonization when people participate in programs like MG Connect. This MG Connect is if you have a smart thermostat and it qualifies for the program, then on like a handful of hot days in the summer, we say like, ooh, energy's gonna get really expensive and the grid's gonna get really stressed. So like, we're gonna call an event. And then we say, all right, we're gonna adjust your temperature, meaning we're gonna keep it there for like 2 to 3 hours. And then what that helps do is reduce peak load. And over the course of energy history, it helps reduce the cost, it helps reduce strain on the grid. We put out reports all the time to our participants. I think we have over 4,000 about how much energy that they just shaved off of the peak load. And the beauty is you're always in control of your thermostat. If it's a day where you're like, nope, I'm home and I have someone visiting who like, they need it to be cool, I can't have my temperature adjusted at all, then you just override it. And sometimes people will call and say like, hey, you must have done something. It's always like, no, we never did anything. Like sometimes their air conditioner just died or something like that because you're always in control. Like you can always override it and still stay in the program. So smart thermostats, MGE Connect, and then
Apps too, because
Oh,
you can smart thermostat on an app, so at any point I can change from my phone. I can just right into the app. I can go and adjust the temperature as needed. Maybe I was like, shoot, I left it at 72 degrees and like nobody's home. Why would I?
Yep.
It's
Or you're
off to
long,
78.
yep, or you're longer, you're gone longer than you thought you were gonna be, all those kinds of things. So we've made it through, right? We've talked about air sealing, insulation, electrical base loads, HVAC, water heating, and then ventilation's a big one. So we say, make this house tighter, like keep all that air inside. Well, it's like, ooh, okay, but that like includes my daughter's like stinky gym socks and like my husband's sweaty gym clothes. Like, so there's also ventilation needed in this picture. And what that does is it removes excess moisture. So where do we want to use ventilation? Bathrooms, kitchens, dehumidifiers in the basements, but we're mainly talking just getting out that excess moisture and in the right way, right? Well, what's the right way? Well, efficient bath fans, range hoods, and they have to be ducted. What do I mean by have to be ducted? Well, you can see in this picture, someone's up in the attic. They actually are taking the ductwork and ensuring that is not just going into the attic, okay? That it's actually going out of the attic to the outside of the home. And we always say, short and straight is the motto. So you want that venting to be short and straight and to the outside. And this is how we, make sure we don't have mold growth, and wood rot and
All the things on that
yeah,
list,
all these
right?
things, right? So ventilation is really important when we say like, let's make this house tighter. True, always true, but then you have to ventilate. So it's built tight, ventilate right.
Yeah.
That's the motto.
And just, one extra piece to that too is, speaking of windows and doors, especially windows, another reason that windows get a bad rap sometimes is, you go to home and they're like, oh, my windows are terrible. Every morning in the winter, I wake up and there's frost and water all over the glass. And it drips down and it creates a mold problem. And I was like, okay, so what we're actually looking at there is we're looking at, there's a humidity source in the home, and that is you, right? And that's your pets, and that's your cooking, and that's your showering.
Yeah.
So
No,
all-
it can't be me. I can't be the
Can't be
problem.
me, right?
It can't be me.
it's us, it's our behavior, occupant behavior, right? So we create, where we, sweat out so much, so many pints of water every day, so the same with the dogs, the plants, everything has moisture to it that it's expelling. And all of that builds up throughout the day. And then you've got a cold surface like a window, and you've got this warm, moist air that smacks it and condensates and it drips down, right? If you're ventilating the house properly, you're going to reduce that amount of moisture that's in the house. And we use a very super scientific workbook, ASHRAE 62.2 type of workbooks to actually determine how much moisture we're going to have to mitigate from the home in order to keep those things from happening. So when people are like, well, it's my windows that are a problem. It's not the windows, that's the ventilation. And sometimes some occupant behavior too. So that's just like one extra side on the ventilation.
Yeah,
So,
good point.
water savers, not going to talk a ton about this. I think everybody, kind of knows a lot about the water saver. City of Madison, has low flow toilet rebates. You can get faucet flow restrictors and low flow shower heads from Focus on Energy for free. You can just sign up for the kits and they'll send that to you. Low flow flush toilets, just use like a quarter of the water that a normal flushing toilet doesn't use. So. And windows and doors, like I said, they get a bad rap. We've said this multiple times. There used to be a company in Madison that they had an advertisement for replace all the windows in your house and you'll save 60%,
At least.
60% on your energy bills. And then people would, and they'd be like, I didn't save any energy.
Yeah.
And it was like, well, there's a reason for that. The amount of cost to replace a window is really, really high. Especially, after COVID when there was all the manufacturing and the supply chain was just wrecked. Really hard to get quality windows that were cheap or, not as expensive. They got very, very expensive. It's very expensive to put them in. It's very expensive the material, expensive for the labor. And a lot of times the little bit of air sealing around those windows is all you need.
Yeah.
To make it more efficient. So when you hear the hype about, that you can save a ton of money by replacing all your windows, it's not true. You have to think of other things to do.
Windows were always last on my energy audit list. They just were never going to provide energy savings. That being said, there does come a time, right? If they're not functioning well, if they're fogging up because the seal is broken, those reasons.
Yeah. I think that's all I need to say about windows and doors.
Yeah.
So, how do you start? How do you get started? So we've talked about a lot of these different projects. How do we get started with them? So there's a lot of things that we can do. A lot of these are projects you can do yourself. It can be weekend projects. YouTube is a fantastic resource for a lot of these projects. You can look up, how do I air seal my box cells? How do I air seal blah, 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 right? How do I insulate this piece of whatever? You can find all of that on YouTube. You can find all those sources there. All those resources are available. And if you don't want to do it yourself, you can schedule an energy assessment with Focus on Energy. Project Home, we do energy assessments through our Optimist division and also through our Weatherization division for people that are income qualified. And you can find all of that information either at Focus on Energy or at projecthomewi.org.
Yes, energy audits
Let's talk
are,
energy audits.
yes, that's where to start. The nice thing about energy audits is that, yes, you could do a fair amount of these things by yourself, but it can be really overwhelming, right? It's like, oh my goodness. And so the thing I found that homeowners loved most about energy audits was like this roadmap that they would get when I was done. It was like, here's what you should do immediately, first two years, right? Here's what you can wait like 5 years to do. And then here's like when you're down the road, right? But the audit will really provide you that like step-by-step like roadmap of where the heck do I go? Where do I start?
Yeah, and having someone that's, building scientist in your home that has the equipment, the blower door, the ways to measure your bath fans, the way to look at thermal imaging, checking the draft on your chimney venting appliances, checking the efficiency of your furnace. Those are the things that we have access to. Most people don't, and it makes a huge difference.
Sure thing. I'm going to try to go through this. We talked a lot. Like how to save energy. Well, if you're moving, use one of our tools. Like every single property in our service area, you can go on and you can put it in and it'll tell you the high, low, and medium of the last year of that place. So the best way you can save is make sure you're moving to some place that's efficient, right? Especially if you're renting, because once you sign that lease, and then, you're not usually getting out for 12 months, right? So use the tools. And then if you are already our customer, use the My Account tool. You can go into your account and put in your square footage and things like that, and it'll tell you like, hey, you're using more or less. And then it at least starts giving you an indication like, am I using more or less? Because lots of times we don't know. And last time I went to a dinner party, nobody asked me how much energy I used. And then, since we're at the library, this is such an easy one, is that like check out your free WhatsApp meter, portable energy meter. You can check out what's using a lot in your house just by using the free portable meter. Check them out, like the book, have it for however long that is, and go sleuthing around your house as to what's using the most energy.
There's currently none available at the McFarland Library.
I was just checked out tonight.
That was so great. And then Focus on Energy, awesome state resource. They run all our energy efficiency programs, and they have free packs. Anybody can go online, you order your free pack, it gets shipped to you. There's 3 different options. That's one free.
Once per year.
Once per year,
Yeah.
yep. And then I love this one. Your house does not care if it's hot, like warm or cold. You care whether you're warm or cold. And so one of my mantras, and there's like some really awesome videos on mgne.com if you want to check them out, is heat the person, not the room. So call me an old lady, but I bought myself some portable heated slippers. So you recharge the battery that are in them, but those puppies will keep me warm for 8+ hours. And look at the cost. If I charge them and use them 8 hours a day for a month, it's going to cost me 22 cents. But if I run a space heater, put that space heater, which seems so innocent and small and just, that's going to cost you $60. So we always have this same message at MG, and it's like, be careful with your space heater. And then the other things are just as nice. I got a vest. I got a heated vest. I just went on Amazon. I got one of the more the cheaper ones just to see how it was. It works just fine. You have to use one of the portable battery packs. But I found that working from home, it was like, why am I heating my entire house? I'm just sitting in this one space, right? I'm an energy engineer, for goodness sake. I have to figure this out. And that's when I realized, heat the person, not the room. They make it so easy for us now. So Christmas presents, these are great Christmas presents for people. And then, of course, I mentioned before, for MG&E customers by 2030, you will be using 80% less carbon than 2005 numbers, because our grid's getting cleaner and cleaner. Now, if you can't put solar on your house, but you're interested in reducing your carbon footprint, we have Green Power Tomorrow, which is a program where you pay like 1 penny more per kilowatt hour, and your wind, and you are essentially participating like in our wind program, and then shared solar. We have had 2 shared solar programs sell out. So they're local. Like one was at the Middleton Airport, another one was on a Middleton municipal building, but they're local solar. And we have a third one proposed to the Public Service Commission. So like fingers crossed. So this is great for like people who want to further support renewable, but probably can't have it on their house. So you kind of reserve a certain amount of panels, and then that energy is yours. Of course, those electrons are not coming specifically to your house, but they're reserved for you. So like our house, our roof is just mid-age, so it doesn't make sense, for us. So like we do shared solar and Green Power Tomorrow, and we're essentially at 100% renewable energy for our electricity. And then if you do want to do solar, I highly recommend taking a look at Google Project Sunroof. Awesome resource. Here's just an example. They have scanned all the roofs, so they can tell you with they can tell you with like pretty good certainty like what you would get if you put in like your average bill, like how much of big an array you would want to get, how much carbon like impact you would have, and then they even give like cost estimates, which I have heard from some installers around town that like they're fairly accurate. So if you want to just like get curious about solar, Google Project Sunroof is like a very good place to start. And then Renew Wisconsin is an amazing organization that has a ton of resources. As a utility, we can't play favorites, so people will call and say like, "Hey, who should I use?" And we can't do that, right? Renew Wisconsin has a little, and then, but the thing about solar is that we get an equal amount of calls at MG&E about like poorly behaving companies. So people that have come door to door saying like, we're partnering with MG&E and you won't have an MG&E bill, right? So you want to be very careful. You want to get 3 bids, do your research, and there are plenty of resources.
Yeah, let me jump in real quick on
Yeah.
that too. So, if you are thinking about solar, and this for me as a NABCEP solar associate, right, is there's some things to think about. One is what's the quality of your roof? Like you were saying, like, your roof is maybe like 15 years old, and like you might have 30-year-old architectural shingles, but you don't know what. Sometimes the roof can play a part in that, right? If the roof is ready to be replaced, I don't suggest putting solar on until you have roof replaced. And making sure that the company that does the solar is treating your roof the way it's supposed to be treated. So sealing, anything that they drill into the joists, is important. The Project Sunroof, the Google Sunroof, great resource because you can see, but a lot of those images were taken a while ago. And if you've got trees that have grown now over whatever you're looking at here, you might, the designer might come out from whatever company you use and be like, well, it's not going to work because now you're south-facing, it's being blocked by this giant elm tree. Good and bad, right? Maybe solar's not right for that application, but maybe there's another way that you can work solar. But then, thinking about it then is, well, it's shade in the summer.
Yep.
So,
Yep.
that reduces the energy, loss in your home. So, like Laura said, making sure that you're using reputable companies for your solar, because there are some poorly misbehaving companies, and really looking at reviews and finding one that's more that's more reputable than others. Those resources are really good, and you can usually get a feel for a contractor based on a face-to-face meeting. So
You've made it to the most exciting part of the presentation. So we love talking about building science. We love home improvements. We realize they come with price tags, and it's not the sexiest thing to say, like, I just spent $10,000 on air sealing and insulation that nobody's gonna see, right? Everybody always wants to show you their countertops or their cabinets. I completely appreciate that. And so that is why I am so excited to let you know about the Inflation Reduction Act. So this was passed in 2022. It's their federal program. It's a federal act. It's taken time to have that federal money come down to the states. In our state administrator is focused on energy. So you've heard us say that because they are our state's energy efficiency program, but they now are helping run the federal rebate program. And so that's really nice because people are going to be dealing with one organization. Bless you. So stick with me here because this is all fairly new and I haven't presented it many, many times. And there's a little bit of like nuances to it, but there's two federal programs, HOMES and HERE. HOMES is our rebates that cover everything that we were talking about tonight, air sealing, insulating, other things too, like furnaces, like all of that, but you have to have an audit and you have to achieve at least 20% savings. So you have an audit, they model the recommendations, and you would have to achieve at least 20% to get a rebate. Now, to make it a little bit more interesting, there's also like tiers of income. So if you're in this 0 to 80 area median income, you get one set of rebates. If you're in the 80 to 150, you get another set of rebates. And then there are some rebates for over 150. So the first thing is to figure out, where do you fall? Now, if you're in that 0 to 80 and you can achieve 35% or greater when you have an audit and you have the recommendations, you're getting 100% of the project cost up to $10,000. I mean, Brendan, you and I have been in this industry for, decades. There's never been this kind of money, right? So our federal government is saying like there's this huge push to use energy efficiently, bring renewables on, and electrify, because here, the other program here is all about electrification. So let's get into them just a little bit. So this is all about like making the home more efficient. And again, you have the audits, and then it's modeled, and then you can see some of the amounts there. I mean, even if you only achieve 20% savings and you're in the 0 to 80, you're getting up to $5,000. So it's a good time to do home improvements. Now, you heard us talk about all this heat pump technology, okay? That's what HERE is really, really advocating. You will see they're advocating for heat pump water heaters. You heard Brendan talk about the heat pump water heaters. The heat pumps for space heating, and they do cooling too, right? Remember, they're that piece of equipment that is like an air conditioner but can run in reverse and heat, using the heat pump technology, which runs off of electricity. And then there also are heat pump dryers. There's induction cooktop, like to replace natural gas stoves and ovens. And then there's even rebates, big ones, like up to $4,000 if you're in that 0 to 80 AMI for upgrading your panel, because you may, if you add this additional electrical equipment, you may need to upgrade your panel. There's even electrical wiring, because maybe you might need to upgrade some wiring. And then if you can't achieve that 20% savings, like let's say you have the audit, but they're like, wow, your house is actually pretty darn efficient, like you can't achieve that 20%, then under the HERE program, you can still get up to $1,600 for insulating, air sealing, and ventilation. So lots of numbers. On top of that, we still have state rebates. On top of that, there's federal tax credit. So being an engineer, I put together a spreadsheet. There will be somebody helping me make this much more pretty. We just need a little bit more time because this program literally just came out like August 1st. But the big takeaway here is if you're in the 0 to 80 and you get an audit, and let's say you air seal your attic and insulate your attic, and that's in like year 1, right? Very doable. You will have no out-of-pocket costs for those improvements. And of course, these are estimated costs. You can't tie me to that. I just kind of put what was applicable. And then let's say in year 2 that you say, well, I'm gonna upgrade my panel. I might need some wiring because I'm gonna get that heat pump water heater. I'm gonna do it. My water heater's leaking, it's gonna die. So I'm gonna go that route. What would normally have been 3 + 4 is 7, 8,500. This is what will be your out-of-pocket for that. Okay. Then let's say you're like, hey, I love my heat pump water heater. I'm not scared of this technology, and your AC dies, and you go ahead and get that heat pump, and you even get like a new furnace. So you have new heating and cooling equipment in the 3rd year. For what could be as high as like 13, could be less, could be more. That's your out-of-pocket. Now, at this point, you've maxed out your HERE rebates. So I didn't include the heat pump dryer or conduction cooktop. But the big number here is that out of all of those improvements, your discount is an 82% discount. Like nowhere ever has there been that discount. No one's given me a coupon to say, here's your 82% off of like $26,000 worth of work, right? So people who are in a position where they need to do home improvements, maybe they need a new water heater, or they don't even, maybe it's just like midlife, but they're like, hey, I want to move and do these things. You're looking at significant savings. And this is your out of pocket on this amount. And then of course, it's even netted less because some comes as a tax credit. Understandably, as a tax credit, you have to have a tax liability and it just comes off, right? But this is exciting time. And then if you're in this 80 to 150, so you're making a little bit more income, this is still like astronomical discount. I mean, if somebody gave me a 50% off coupon, you'd be sure that I would be like, yes, this is motivating me to move forward, right? Because some of these things just end up having to get done anyway. Like we needed a new dryer. We needed a new water heater. Like these things happen in homes. And so the idea is, and then I don't have a slide, but for the people in the 150% of the area median income and higher, they're at like 26% savings. That's nothing to sneeze at either. Like I for sure am that person that cuts out the 25% off coupon and goes to buy something at the store specifically because I'm gonna save 25%, right? So the point in all of that is that there are just some very, very, it's just a very, very good time to think about doing all these, and through this HERE program is like phenomenal. I mean, you can get 100% up to 14,000 and then 50% up to 14,000, depending. And, the beauty of working at MG&E is they support my role in the residential department to be able to talk to people. So if you need and you have questions and you're like, oh my gosh, I heard all this great information, but it was like so much information. I am available at the Home Energy line, which is 608-252-7117. And I am allowed to talk, to customers and navigate through this.
Yeah.
So,
Yeah, thank you for that. I mean, it is a great time for a lot of these things, and people need to take advantage of it because once it's gone, it's gone. So
thank you. That being said, I have heard, like, even though it's millions and millions of dollars, it will go fast. So, like, we're talking, like, in the next, like, 4 to 5 years, you want to be getting these things done because it could be gone. And once it's gone, it's gone.
Yep.
Yeah, good point.
So there are a lot of resources out there. MG&E is a great resource. Project Home is a great resource too. Especially if you're looking to do an energy audit. We can do that. There's plenty of other contractors that do energy audits, and as long as they're doing all the things, then you're getting a good bang for your buck. So, but it helps a lot with being able to, like you said, get that roadmap and have someone that's a building science professional in front of you to be like, okay, this is my main issue. How do we fix it?
Because oftentimes the roofer will believe that they know everything about X, Y, and Z, but then the electrician knows everything about X, Y, Z.
Yep.
And it's like the building science person knows how that house works and has seen it, and we're not selling anything other than building science. So,
Yeah, I mean, there's a lot of great resources. We've got them all up on the screen here. And like I said, Project Home is a great resource too. And we've been around for a long time, and we're actually just down the road from McFarland here, so it's a hop, skip, and a jump. So that concludes the Saving Energy in Your Home slideshow. Does anybody have any questions? Thanks very much.
Thank you.
Yeah. Happy to be of service. So.
Very informative.
I do have one. I just wanted to cancel the recording so I don't go an hour 30.
Yeah.
I have heard about this myth, and I've been very curious about it, to the point where it actually like drives me insane when my significant other will like touch the thermostat. So like, is it possible? Oh yeah, I'll clip. I appreciate it. So like, I've heard this myth. I'll just say the myth and tell me if it's true or not. So in my mom's house, she would always keep things at like 78 when she left. And then when she came home, she put it down to 72. I have heard the myth that that is costing you more money in the long haul because that initial heating from going to 78 down to 72, it costs you more than if you had just kept it at 72 all the time. Do you know if that's a thing that is true, or is my mom like onto something?
I can answer.
Yeah, I mean, I think we both probably have a fairly similar answer to that. So, the thing about whether you're increasing the heat or increasing the cooling, right? So whichever way the swing, in larger zones, right? Like 6 to 8 degrees, you have to think about it's not just cooling the air; it's cooling every surface in that house, right? So
Right.
if it's at 78 degrees and you want it to be 72 degrees, and you turn on the AC, you're cooling every surface in that house because everything's giving off more heat, right? So in that swing, I would say yes, you obviously use more energy for that swing, which is why most people usually have a much smaller swing, right? Or they'll drop their temperature down real low at night to be able to bring it up. So
Right.
In that swing, obviously, you're using more energy, whether it's for AC or for heating, to not only warm or cool the air, but also the surfaces as well. So the short answer is yes, you do use more energy there. The long answer is you use more energy for a bit. And then when you hit a steady state, a furnace is supposed to run longer. AC is supposed to run longer because you're getting other benefits of that, the humidification, or in the case of a heating system, right? You're hitting a higher threshold of steady state, right? So it becomes more efficient as it runs longer. So people that short cycle their furnace and their AC actually end up using more energy than people that run it longer. So,
I'm gonna smack her hand next. No, I'm just kidding.
so yeah, that's the.
That's awesome. I've always wanted to know that.